Hello everyone, we're from RSA Math Institute and today we're going to show you our latest product, the Taj Mahal. The Taj Mahal is made of many functions like quadratic, circular, as well as exponential functions. There are actually 350 of them in total, which we'll show you today. In this video, we're going to cover our thinking process, the different types of functions like transformation and the endpoints as well, and then we're going to conclude our video by showing you a brief summary of what we did.
Firstly, we'll be talking about horizontal and vertical translations of functions of the graph. Vertical and horizontal translations are whereby we alter the domain of functions, either fx plus c, to alter vertical translations parallel to the y-axis, or fx minus c, to alter horizontal translations parallel to the x-axis. Let's take a look at this oval of the left tower closer to the main building. The function for this specific oval is as such. For vertical translation, we have altered the y squared to become y minus 4.23 all squared, moving it up from the original y equals 0. As for horizontal translation, we have altered the x squared to become x plus 3.278 all squared, to move the x-axis right by 3.278 units. This allows us to plot the oval's middle point at the coordinates negative 3.278 and 4.23. Using translation, we are able to alter and move functions accordingly across the graph more precisely and accurately.
Now, let's talk about reflection in transformation. There are two primary types of reflection: reflection upon the x-axis and reflection upon the y-axis. In our project, we mainly used reflection upon the y-axis as our artwork was mainly laterally symmetrical. Reflection upon the y-axis is where we flip the graph upon the y-axis onto the corresponding positive or negative x-value ranges. The function for this type of reflection is f bracket negative x, to flip the function onto the other side of the y-axis. An example is these two functions that we use for the roof of our Taj Mahal artwork. As you can see, the only difference between these two functions is the negative sign in the exponential graph's power, whereby we have imputed negative x and x to flip the exponential function onto both sides of the x-axis as such. This reflection allowed us to save time, as we only needed to input the function on one side and reflect it onto the other side of the x-axis.
Now let's talk about enlargement and endpoints. Enlargement of a function requires the center of the shape, maintaining its ratio, and also increases the size. We did not really use this form of transformation except for the circles on top of the roof. As for endpoints, we use this the most to cut the functions off at a certain point. For example, this function right here, for the base of the building, use endpoints with a difference of a negative sign to keep the building symmetrical.
Finally, let's talk about our thought process and ideas. We actually have a few strategies to try and quicken the process of construction. At first, we did many things through rough estimation, especially for the linear functions, such as those for the base and towers of the graph. However, we started to experiment with using the sliders for the more complicated functions, so as to speed up this process even more. As for a list of all the functions we have used linear functions, fx equals mx plus c, quadratic functions, fx equals to ax squared plus bx plus c, exponential functions, where fx equals to e to the power of x, circular functions, where x minus a all squared plus y minus b all squared equals to r squared. And lastly, we used oval functions, where x squared over a squared plus y squared over b squared equals to c. With this, we were able to make the primary structures of the Taj Mahal, like windows and roofs.
Lastly, the toughest challenge that we faced was that the main gate was a very oldie shape, so we had to actually use our decision making and trial and error to figure out how to make the functions that you can see above, and that's our biggest decision.
We have come to the end of the presentation of our product, the Taj Mahal. We hope that you understood the process and the functions required to make this art piece possible and consider buying it. I am Shuhan.
I'm Rico.
And I am Axel.
Thanks for watching.
Thank you for watching.